Question 11, which is the last question of this paper. This question is about sodium sulfate. A teacher finds an unlabeled bottle containing a white solid. Describe test to show that the white solid is sodium sulfate. Okay, first one, in order to test the sodium ion, the student must do a flame test. And the color of flame is yellow. Then, in order to test the sulfate ion, the student must add hydrochloric acid. Add hydrochloric acid. And then add barium chloride solution. And then the result is the white precipitate will be formed. Okay, then question B. A student has a sample of crystals of hydrated sodium sulfate. The student uses his apparatus to find the value of X in sodium sulfate with X water. So this is the student's method. Find the mass of the empty crucible, then add some hydrated sodium sulfate crystal to the crucible. Find the total mass of the crucible and hydrated sodium sulfate crystal. Heat the crucible to remove water from the crystal. Find the mass of the crucible and its contents every 2 minutes for 10 minutes. So the table shows the student result. So question I, state how the result show that all the water has been removed from the crystal. So you can see that the mass after 8 minutes and 10 minutes are constant. Okay, so the last two results are constant, or you can say are the same. Then calculate the mass of anhydrous sodium sulfate remaining after heating. So remaining after heating, right? Mass of sodium sulfate remaining. Okay, so mass of sodium sulfate equal to 26.79 minus 23.57. Okay, so we will have 26.79 minus 23.57, which is equal to 3.22. I have to change this one a little bit, in fact, because it has some water here. It's not a pure sodium sulfate. Then, if you want to find the mass of sodium sulfate after heating, right? So we will have 24.99. Let me move it here. Mass after heating is 24.99. minus 23.57, which is equal to 24.99 minus 23.57, which is 1.42. So the answer is 1.42. Then calculate the mass of water lost. So mass of water lost equal to 3.22 from the previous question minus 1.42. So it is equal to 1.8 gram. Then use the student's result to calculate X in the formula of sodium sulfate with X water. So we have the mass of sodium sulfate, which is equal to 1.42 divided by mR, which is 142. And we will compare with the mass of water loss, which is 1.8 divided by mR of water, which is 18. So it is equal to 1.42 divided by 142, which is 0.01, and 1.8 divided by 18, which is 0.1. And since 0.01 is less than 0.1, so I will divide on both sides with 0.01. So it will be 1 and 10. So therefore, the value of X equal to